So my talk tonight is called NLP, What You Mean, Not What You Say. And this is a bit of a deep dive into real-world NLP, kind of going a little bit away from, research papers, theories, tutorials, and more into what does it look like when you run a somewhat complex NLP stack in production in a real product. So here's a kind of contents of the talk. First, I'm just going to give you a little introduction to our company, Aidan AI, and just to give a bit of context into why we built our NLP stack. Then quickly talking about what the expectations of what people think NLP works like versus how we found out it really works in real life. And then a couple of lessons we've learned trying to build this NLP stack. And that's basically it. So very quickly about myself, my name is Ling. I'm a Kiwi, but I'm living in London right now. I'm a software engineer. Currently, I'm working for Aidan AI, which is Young's NLP startup, AI startup based in Angel. Previously, I was an entrepreneur first, and my specialties were in NLP, speech recognition, and machine learning. And who is Aidan? So Aidan is our virtual assistant. Mostly today, he lives on Slack. And he is a virtual marketing colleague. And so what does that mean? So if you're a marketer, in digital marketing these days, we're running hundreds of campaigns in all different languages and countries on different devices. And it's not very different from a machine learning problem. You kind of guess your parameters. You say, I think this kind of ad is going to be really popular in the UK for iPhone users. You run your experiment. You get some feedback. You analyze your results. And then you try optimize your hyperparameters and try constantly driving your revenue higher and higher. So, ads have planning, which is, you plan what kind of ads you're going to run. This is largely still human. And then you have implementation, execute these on Snapchat, Facebook, Instagram. Then you have mass monitoring. So you're monitoring hundreds of campaigns or thousands of campaigns running simultaneously in different countries. And you want to do different types of data analyses on these. And finally, you do reporting. How did we do and how can we improve for the next cycle advertisement? And Aidan's idea is it's supposed to be, you can imagine if someone asks you, if your boss asks you, oh, hey, I'd really love to know how we're doing for iPhone in France and the UK this week. And then you go and you spend half a day downloading data from different backends, putting it all in Excel, doing some pivot tables, and making a nice graph in the end. And Aidan is like your really great intern who will just do that for you, and you can take over credit for it. So here's a few things that Aidan does. You can ask for data straight up in natural language. Compare my CPI in remarketing versus prospecting last week. You see you get a nice chart and how much your CPI means cost per install. So this is for two different types of ads. You can see here remarketing is outperforming prospecting here. On the right-hand side, spend and revenue week over week last month. Very simple queries. You just get how much you spent overall and a graph of a spend by week. You can do simple types of analyses. So you can say, you can ask questions like what was the best, what was the worst, what had zero. So what country did I spend the most in last week? It just looks at all your data and tries to do a simple inference on what the right answer is. And you said you spent the most in the United States by a large margin, it seems. Other things Aidan can do is you can do context. So you can say, hey, what was my daily cost per install versus budget spend for the last 2 weeks? And you get the graph as normal. But then you can say, and what about in the UK? And he knows that you're still looking at cost per install and on budget spend on a daily basis over the last 2 weeks. It keeps in memory what we've been talking about recently and does a follow-on so you can see the next graph is the same as the one above, just filtered specifically for the UK. And we have some simple data science as well now. So you can ask Aidan to do stuff like predictions about the future. So how much am I going to spend this month? You can see we're halfway through the month and it has your data. And based on this and historical information, Aidan will try and project into the future with some level of accuracy. And of course, it can do monitoring. So one of the really nice things about Aidan, like other coworkers, is you don't have to tell Aidan exactly what you want to do. It'd be very tiring if everyone under you had to tell them exactly what to do every day. Aidan has some idea of what good and bad advertising looks like, and he's always watching your data in the background. And if he notices anything out of the normal, he alerts you proactively. So he has some idea of what you might be interested in advance, and so that he can be helpful to let you know about all the data, which is now nowadays, there's so many campaigns you're running, it's impossible for you to manually keep tabs on them all. And Aiden can sometimes tell jokes, but he's not very funny. We don't spend too much time writing jokes, but our CTO loves knock-knock jokes. So if you ever do get to try Aiden one day, you can have some fun trying to look for all the Easter eggs. So that's just a bit of context about who Aiden is and how the product works. But the real question of the talk is, what does an NLP stack look like in production? So here we're just going to look at the difference between kind of how people think NLP and bots work versus the reality of a situation. So if you go to Google and you Google, hey, how can I create a chatbot in X minutes? So I just tried this a couple of days ago. You find a lot of results. There's a lot of articles on Medium and Chatbot Magazine trying to tell you you can get a chatbot going in 45 minutes, in 10 minutes, in 30 minutes, in 12 minutes. So people disagree with how long it takes, but the idea is everyone thinks you can do it in under an hour. And this guy, who's the founder of a chatbot startup, first his article published was how to build a chatbot in 7 minutes, and then he edited it to 5 minutes because he thought it was too long. So in a very quick primer on NLP, the main part that's important in the context of building bots is you have these two concepts called intent and entity. So intent is what you think the user wants, and entity is the parameters of what they want. So in the first example, how many installations do we get in the USA? The intent is metric query because the user wants to see some metrics. And the entities are the parameters. He's asking for installations specifically in the last week in the USA. And so if you think about this as an analogy to programming, intent is like the function you want to execute, and entities are the parameters to that function. And all the articles that tell you how to build a chatbot, they're all pretty much the same. You sign up for one of these APIs, which are very nice. Dialogflow, Luis, Watson, all popular ones these days. You kind of give some examples of things your user might say, and you label them with the correct intent and entities. And then you can either run your own server, or it's very popular now, they try and push you onto these serverless architectures like AWS Lambda or Google Cloud Functions. And in some way, you hook up this intent onto some kind of backend or database, or maybe it's just a plain response. And then you just let it happen, and then everyone talks to your bot, and you make a lot of money, and you go talk to VCs and hire everyone, and it's a great and happy life. So if we take a look at some of the bots that are quite well known and quite famous and see how they work, not to be picking anyone out, I just literally went to our Slack channel and picked the first 3 bots, which are in our Slack channel. So the first one is Polly. Polly is a bot that helps you make polls in Slack and to ask for your team's opinion on certain things. So first I asked Polly, hey, can you make a poll? And he says, sorry, I didn't quite get that. Just say help to find out what I can do. So he's not too happy with natural language, and I say help. And you can see here, he's trying to kind of push me towards using these /poly commands. And these commands are actually, you type /poly, and you type the question you want to ask. So really, he's pushing me towards using parameters directly. So this is similar to the IRC chatbots we've had like decades ago. And it's completely command-based. There's no natural language. And actually, if you try create a survey at the bottom there, you can see he's actually pushing you a link to an external app to make it outside of this chat interface completely. So not much natural language processing, basically. Another one is Satna. Satna helps you do daily stand-ups for your team. They have great open source packages as well. Seems like a fun, nice team. I asked Satna, what can I do? And he says, whoops, I don't understand. Here's how I can help you with the following. And he has a list of, again, one-word commands. Configure, check-in, profile, support. And if you ever make one of these products, you'll realize that users never read what you tell them to do. So I didn't read it, and I said set up instead of configure. And it says, oh, still don't understand, let's do it again. So you can see here, again, same thing, no natural language, all command-based. Another one is Howdy. Howdy lets you run regular scripts, so prompt the team every week to do something. I say, howdy, hello. He says, oh, hey, and here's some options. Gives me some nice buttons. Click. And I don't want to click buttons. I want to say, what can I do? Help. Hello. And Howdy just kind of says, I need input. It has a bit of a freak out. And then I say, can you schedule stand-ups? What can you do? Help. and help trigger something. So actually this guy doesn't want to do even commands. He only wants buttons. Only the buttons will get you anywhere. So a lot of Facebook bots are actually like this as well. They push you very hard towards buttons and want you to click on those. So the difference we've seen is that online, they tell you can build a chatbot in under 1 hour of natural language. But in practice, all the kind of semi-famous chatbots, not all of them, many of them are using buttons, commands. They've kind of steered themselves away from natural language. And what's the reason? There's a lot of reasons, actually, that NLP, basically it boils down to the fact that NLP is very, very hard. And here's why it's hard. One is that users don't know what you can do. There's a very big fear of the white box syndrome. If you show a user just a white text box, they don't know what to do with it. They don't even know where to start. Number two is users don't know what not to do. So if you give them a white box and they start trying things, probably 80% of things they try are not features you have. And it's going to be very embarrassing. Another is users are very vague. Sometimes we get questions from our users towards Aiden, and we look at them and we don't even know what they're trying to ask for. So they can be very ambiguous a lot of the time. And sometimes a big problem is they ask questions that you understand, but they're logically impossible. So often we get this question from a user where they say, what's my ad spend on this? But there's no ad spend on that thing because that thing doesn't track ad spend. So the whole question is illogical, doesn't make any sense. So even if you understand it, you can't always execute it. Sometimes users use concepts that you don't know about or aren't in the data. So users have this idea of how, for example, in our case, how the marketing department works, but it might not be how it actually works, or it might not be how it works in the code or in the data. And so they have their own concepts in their head, and they're going to use those concepts to ask you these things. For example, you might say, a simple one would be, hey, can you let me know on Easter what my spend is? And maybe your bot doesn't know about Easter yet because it's just not anywhere in the code, it's not in the data, but it's in their head. Users' flow is unpredictable. This means that users are kind of hyperactive and minds all over the place. You'll be trying to guide them through something like setting up some kind of background monitoring, and they'll just get bored halfway through and start talking about something else and ask you different questions. And so even if you try force the user along certain paths, it's only going to annoy them and get them confused. And we found that basically we have to let the user do whatever they want at any point because, well, that's what they want to do. And you don't have buttons or form validation or anything like this to validate or control them. Basically, it's a text box. They can do anything they like. And lastly, NLP models, like any machine learning models, are extremely unreliable and extremely unpredictable. So they sometimes break, and you have no idea why. So the combination of these reasons is, in general, a big factor that stops a lot of companies actually tackling NLP, and they just kind of give up and say, well, let's just do commands or let's just do buttons for now. So we, as you saw from our very short demo, we did maybe foolishly try to do real natural language. And so here's a few of the lessons we've learned that kind of made it a little bit less crazy or a little bit less scary for us. Number one is this idea of NLP model complexity. So complexity looks like this. As you add features, the complexity of your model grows very, very quickly. I'm not going to say exponentially because I don't know how quickly, but it's more than linear. And what does complexity mean? So roughly, the complexity means how hard is the problem you're trying to solve? How hard is it to correctly identify what the user wants and with what parameters? And it grows very quickly as you add more features. And that means as the complexity grows, two things happen. One is that your accuracy falls a lot. So just adding one feature will make you have a much higher error rate across the board, across your whole app. And secondly, you need much, much more data to reach the same level of performance. So you might need to spend much, much more time annotating data, gathering example utterances. So basically, complexity is a very bad thing, and it's a very scary thing. And this is kind of how the investment looks. So for maybe your first 3 or 4 features, you can do it in half an hour. It's very easy. You add it to 8 features, and you're like, not so bad. Takes a couple of weeks, spending time annotating, managing a model. You grow it to 12 features, and now you're looking at months to make sure that this model works correctly. And when you go to 16 features, and now you're looking at years if you wanted to do it this way. So as you can see, as we add the number of features to our product, this problem becomes much, much harder in a very fast way, and you're very quickly going to run into the point where it's intractable and it kind of overwhelms and defeats you, and you just give up and use buttons. But so with its complexity, basically as complexity grows, your amount of spend grows, spend meaning how much time you got to put into it and how much money you want to put into it. So, I mean, if you're Google and you have unlimited money, this does not really have to concern you. You just hire more people, more engineers, and just keep going at it. But if you're a startup, it's going to be very scary and it's going to waste a lot of time and a lot of money. And the other thing as a startup is you have a lot of tension here because you have the opposite need as well. You need to add features very fast. You got to keep iterating. You got to keep trying new things. So if you kind of just let it do its thing, it will feel a bit like this. Every time you add a feature, another one will break, and you're going to keep adding features, and things are going to keep breaking everywhere. And it's going to be very painful. You can spend entire days doing this. So there's a really important need comes up. Can we slow down this growth and complexity without slowing down our product development? We need to keep adding features. And the answer is yes. We can use principles from software engineering to manage this complexity. Because if you think about it, it's not that different from a huge code base that at the beginning is very messy, no unit tests, and just kind of doing its own thing and breaking over time. If we use some good engineering principles, we can kind of control its growth and make it stable. So the first question is, do I really need something new in our NLP model? Can you reuse something? So before you think about adding a new intent or a new category to your NLP model, think about, is this similar enough to something that already exists? Can I just reuse that one thing? Be very careful of adding new entities. Sometimes we just add a new entity just to try it out, and it breaks random features like in completely unrelated parts of our code because you have a black box magic NLP model, and it does whatever it wants. The second part is actually very important. Don't be afraid to use code or regular expressions to just hack things away. Hacking is fine. Everyone does it. I once spoke to someone at Google Translate before they have a new fancy Google Translate. But the old one, there were like thousands of hard-coded rules for Turkish. It was just, it wasn't nice at all. It was just engineers going in and hacking away at it. And it worked. It worked pretty well. And the analogy to software engineering is don't write code when there's something similar already. Always try to reuse it. Less code is better. And the same idea. Smaller model or less intents and less entities is much better. So here's an example. If we have two intents, one is like alert me. So ping me when my spend is over $1,000. And we have another intent called chart my spend last week. And say we have a new requirement. They say, OK, I don't just want to chart now. I want to chart as a follow-on to something else. Can you let me know when VAT is over, can chart that over the last 2 weeks, or ping me when VAT is over $1,000. So this is a new requirement, and the first thing everyone thinks to do is, great, 2 more intents, just put it there. But what you realize is when you have to train everything you have in the first one, you're going to have to create a new training example for the second one. So if you have 1,000 examples, you have to write 1,000 new examples for each of these categories. And another way you can do this is just do this. Look for the word VAT, and if it's there, it's a follow-up. And this will take you about 5 minutes, and it's not perfect, and there's a lot of flaws in it, but if you're moving fast and you have a model you need to iterate on, it does actually work quite well, and at least it's controlled. It's not going to break anything else in your code. It's not going to break anything anywhere else, and when it breaks, you at least know why it breaks. So don't be afraid to hack things. Another one is, can I simplify my model? So with all products and all startups, as you're developing, your requirements change over time. Users will say, I need this thing, and you build this thing, and then they say, well, I don't care about that thing anymore. And you're always adding new things in a kind of organic way. But just like code, sometimes it's time to step back and think about it and say, well, does this make sense? Can I simplify this? Can I reorganize it? And can I refactor my NLP? And an example is, we have these two kind of intents where the reason they're different is because in the beginning they were talking to different backends. The data was being fetched from different places. One was, what is my CPI on Christmas campaign? Another is, what's the end date of Christmas campaign? So if you just change the word CPI for end date, they're basically the same, almost. But originally we thought, they're from different data sources. Let's make them different intents. And then your annotators will look at it and get a little bit confused. So we said, just make them the same one. Problem solved. We don't get any no more bugs trying to differentiate between them now. Actually, a good test with this is try get some people, especially people who are a little bit more away from your project, to try annotate examples for you. And if they are having a hard time annotating, it means you have ambiguities and you have to refactor your intents. And modifying your NLP model on the fly is the same as modifying your server in production, because basically you will change something and your features will start breaking and you won't know why, and you'll change something else and everything will be on fire all the time. So it's a good idea to treat your NLP training data and your model just like you treat your code. Check it in, build it, run a bunch of tests on it, have a separate testing set that we think this should work, or we think this should work with at least 90% accuracy. And then every time you add something to your model or you add some new training examples, check it in and test it against that set again. And only deploy when your test code green. It is very annoying and it'll slow you down, but it's much less annoying than playing whack-a-mole with your NLP. So that's the first one. We want to try make sure we can basically slow down our NLP complexity growth. Second one is that in building any natural language product, you need to rely very, very heavily on context. There was a talk actually by one of the product managers on Google Assistant, and he was saying I think around 50 or 60% of all queries on Google Assistant use context in some way. So context is extremely important, and you're going to miss a lot if you don't use it. So your perfect user will say something like this. Hey Aiden, can you chart my spend in the UK for the last 3 weeks on a daily basis for the campaign Christmas? And if you give this to Aiden, he's very happy. He'll be like, I'll do exactly that for you. Here's your data, that was easy. Unfortunately, no one talks like that. A real user will say something like this. What's performance recently? And they want to see roughly the same thing. So you say, okay, well, what should I do here? There's a lot of questions we have. What does performance mean? It means something different to each person. I don't know. What account are you looking at? I don't know what data, you have access to a lot of data, but which one do you care about? What do you mean by recently? What time granularity do you want that? Do you want it by day, by week, by month? What countries, departments, devices, ad platforms do you care about? And this is what context means. Context is, take a guess. So if you ask that to Aiden, he'll say, okay, I think your KPI is set to installs. Just ask me if you want to change. You're looking at retargeting campaigns recently. You have this many installs in the last week. And then he asked, did I get your question right? So if you break it down a bit, what does Aiden do? First thing is he takes a look at performance and he tries to deduce it based on your preferences or recent queries. Then he looks at time frame and he says, okay, I think something reasonable is 1 week. 1 week seems like what most people would be happy with. He takes your campaign you're looking at from your account settings as well. And finally, but very importantly, he asks for feedback so that you know that if your guesses are good or bad, you can constantly improve this process. And so designing for context means design by imagining your user is going to give you very little information. They're just going to tell you a little clue of what they want, and you've got to fill in with blanks. And the way you fill that in is you combine expert knowledge. So we use people who've worked in marketing, who know what marketing analysts are looking like, to tell us, well, when I say this, I probably mean that. We use the user's preferences, so you spend some time upfront, asking the user, hey, what do you care about? What do you want to look at? How do you like things? Or we can ask them on the fly and just remember it. So preferences is very important. You look at the history, so you look at what has the user been talking about recently to kind of guess what they want. And we also have to ask for feedbacks because we make guesses, but we get them wrong. But with this, you can have it's not that difficult actually, but and you can get a pretty robust process, and at least you give them something each time, and you can make that something a little bit better as you learn more about your user. And finally, the last concept is quite an important one. It's that the concepts people talk about is not the same as the data you have and the data you're working with in your code. So questions look simple on the surface. What's the return on investment on retargeting campaigns? Aiden says, I think it's about 120%. Well, it's exactly 120%. But the problem is, it looks simple, but we might have this kind of scenario where I'm looking at revenue, but revenue comes from an internal database inside the company's firewall. Ad spend is on across 2 backends, across Facebook and AdWords. The Facebook marketing team is tracking installs as a KPI, but maybe the AdWords marketing team is tracking mobile purchases, so they're not even looking at the same metrics. And inside the code, different departments have their own system of labeling things. For retargeting, some people use RET, some use retarget, some just use RT. Like the data is totally not consistent across different teams, across different databases, across different backends. And we got to deal with all of that. And it's going to look like this. You have a very simple question, and you're going to be querying data everywhere. Like, data is going to ask for other data, which is going to ask for other data, and it's going to be very, very confusing. But the key is we don't want to surface this complexity to the user. If they wanted this, they would just open all the dashboards, open all the web apps, export everything to Excel. They just do it themselves. There's no point making them go through that same steps with a virtual assistant, because it's just worse. So if you do ask him something, how much did I spend on remarketing? He says, okay, checking, you spent 640K. And actually, this question takes over 1,000 API calls to answer, because it's across backends, across all sorts of things. And we abstract it away. So the idea is, your product needs to stay in the user's concept land. Don't take them into the data. The whole point of natural language is so that you can interact with products in a natural way. If you're going to take them all the way into the data, it's like you're doing dashboards and buttons and these terrible IBM apps again. And so keep it simple. And remember, they don't even know, most users, especially most of your users, will not be technical. They'll not be thinking in terms of the data. They don't even know what the database looks like. So don't take them into that land. And so here's how it kind of works. Users have this ideas in their head of how the world works. And there's the data in your databases. And sometimes there's a bit of overlap. That means the concept is the same as the data, maps one-to-one. But most of the time, they're very, very different things. And so we used to get confused a lot, because in our code would have sometimes parts coming from user land, sometimes parts coming from data. Everything was mixed up, and we got very confused, and Aiden got confused a lot. But now we have a separation where we say, in our NLP and UI layer, you can only use the user concepts. You cannot touch any of the data concepts. And in our execution mode, everything of the user concepts gets translated, and everything is executed with data concepts. So it's important to realize which one is which and keep them very separate from each other, and so that you don't get confused, basically. So that way, the user will not ever get shown complex data ideas, because the objects are not even there in that space. So that's pretty much it. That's basically 3 lessons we learned in trying to build an NLP system that works. We still have a lot of NLP problems, but we're trying to manage our complexity. We're trying to use context a lot, and we're trying to make a clear separation in understanding of what the user's concepts are and what our data is. And with this, we're getting some way there, and we have a lot more to go. But these are kind of a few of the most important lessons we've had so far in building a real NLP product. So thanks for listening today. Feel free to come have a chat with anyone in our team afterwards. We are hiring, and if you're interested in our product, just come have a chat with us. Thank you.